Hello everyone, we are student from the Department of Data Science, GM University, Davangere. Today we are presenting our assignment project based on KNN classification. Let's introduce our team members: Akash J, Balaji, Parjwal C S, Darshan H M. And I am explaining about my topic. What is KNN? Uh, Simple supervised ML algorithm classifies based on nearest neighbors, non-parametric and the instance based. Uh, on this slide, we introduce the KNN algorithm. K stands for K nearest neighbors, and it is a simple supervised machine learning algorithm used for classification. This idea is very initiative. K classification is a new data points by looking at the closest labeled points in the nearest boards. It is a non-parametric instance-based method, meaning it it does not build a fixed model during training. Instant it makes decisions based on the existing stored data points. How KNN works? Find the distance between simple and all points. Pick a nearest neighbors. Pick a K nearest neighbors. Majority voting decides class. Uh, in this slide explain the working of KNN algorithm. First, when a new data simple comes in, we calculate it distance from the all data points in the data set, commonly using education distance. In then we selected the k coolest neighbors. Finally, KNN checks which class is most common among those neighbors and assign that classes to the new sample. This is called majority voting. Because of this sample machines, KNN is easily to understand and implement. Next will be continued by Balaji.
So now I'm going to explain about here code. The slide describes the processing steps like dataset loaded using the pandas, next target variable species, encoded using label encoder because ML model needs a numeric labels. So next futures X and a target called Y separated for the training. So this shows the dataset was prepared properly before applying the KNN. So here code explanation training the KNN. You explain how the model made test multiple k values like k is equal to 1, 3, 5, 7, 9, 11, for example, calculated accuracy for each k. So best accuracy observed at k is equal to 5. So this shows the hyperparameter turning testing the best value of k. So next will be continued by the Prajwal CS.
And here is the output that the KNN is worth accuracy versus K graph. The graph shows how the accuracy of the KNN model changes when you try different values with the K. And K is equals to number of neighbors used in prediction. The graph helps to choose the best K value with the nearest accuracy. Confusion matrix. This chart shows well This chart shows the well of KNN classified data. It compares actual labels versus predicted labels. Off diagonal boxes is equals to mistakes. And now real world applications of KNN. It recommended the system and the medical diagnosis, image classification, and credit risk analysis, pattern recognition. The next part will be continued by Darshan.
Advantages of AML: simple and easy to understand. KNN based on the distance, no complex max or training process, non-training time. Since KNN is lazy learning, it does not build a model behavior. It calculates distance during prediction. Work well on small data sets. When data is small, KNN can give accurate result. Conclusion: KNN effects for iris data sets. KNN is data simple and widely used for testing classification algorithm, and KNN performance will non it easy to implement and interrupt. KNN logically straightforward, find the closest near neighbor and predict the majority classes. good performance with the right k. Choosing the right value of k, the number of neighbors is improved. It is too small and too large to generalize. Generalize again could improve the accuracy. It won't